Now, I've provided you with a radical sheet. These are all the numbers that square root into a perfect integer, the square root, okay? Cubed roots. These are all the numbers that cubed root into a perfect integer, like yesterday. So the cubed root of 8 is 2, the cubed root of 27 is 3. Now the reason why the cubed root of 8 is 2 is because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, vice versa. I've also got fourth roots, okay? 2 times 2 times 2 times 2 is 16, and so forth. Now, again, if you're on virtual, you might want to pause the video, write what I got down, find all real square roots. And the first example, 625. So you're going to put a root, and it's going to be a 2. That's a square root. So the square root of 625, now it's positive, or it's even, my bad, it's even, so it's going to be a positive or a negative. Now I want you to use your calculator to find that. Here's how I want you doing it, okay, so you don't get confused. Throughout this unit, I want you to hit a 2. I want you to hit the second button. I want you to hit the caret symbol. So that'll tell you want the square root of 625. And it's 25, so it could be positive or negative 25. Okay, now square root of this. So we know since it's a square root, it could be a positive or a negative. So I go 2 second and then the caret symbol, 0.0025. 0.05. If you're on virtual, if you don't have one of these calculators, you better hustle to Walmart and get one, because this is the way I'm going about it. Okay? Okay, next one. -4/9. Okay? That's my phone. I'm going to wait for it. I'm not going to answer it right now. Come on. Go to voicemail. Good. Thank you. Okay. All right. The square root of -4/9. Okay. Now the answer to this is none. Okay. Now the reason why it's none, because watch this. If I go 2 second caret, okay, just like that, and I go -4ABC9. I get domain error, so that means none. The reason why is because you can't have the even root of a negative number. You can have the odd root, just not the even root. And then 25/144. So I put a square root over that. There's no negative, so it's going to come out. So 2 second caret, or 2 second caret, 25 ABC 144. Okay. I got 5/12, but again, it could be positive or negative because it's even, okay? Okay, and that makes sense because the square root of 25 is 5, and the square root of 144 is 12, so it's 5/12. Okay. Now, our next section says find all cubed roots of each number, cubed roots. So that means I put a root over it, and it's a cubed root. Now, having an odd also opens up the possibility of negative, so I go 3 second caret -27. And I get a real number answer. I got -3, so there's no domain error. -3, but it's only -3. Odds only have one answer. It's not positive or negative, just whatever we get. Okay, next one. Apply a radical with a 3. So 3 second caret 0.343, 0.7. Okay, and again it's odd, so it's just the one answer, not a positive or a negative. Okay, next one, 3. So I go 3 second caret -8 ABC 729. Okay, I got -2/9. Because the cubed root of 8 is 2, but since it's -8, it would be -2, and the cubed root of 729 is 9. Remember, it's not going to say domain error if it's an odd root. Okay, it'll say domain error on a negative if it's an even root. Okay, and we're not doing I, because when it says find all real roots, that means we don't use I, we just write none. Okay, then the cubed root of negative 8. So what times what is negative 8? Well, it's got to be a negative, we know that. Be negative 2. Okay, now go to the back side. Find all the fourth roots of the given number. So you've got 81. Now you're doing fourth roots. Okay. Now, even back to an even root, so it'll be a positive and a negative. Okay. So I go 4 second caret 81. So what times what? It's 3. Makes sense because the fourth root of 81 is 3. Because 3 times 3 times 3 times 3. Okay, next one. Put a fourth root over the 256, positive or negative. So I go 4 second caret 256, and I got 4. Because 4 times 4 times 4 times 4 is 256, but so is negative 4 times negative 4 times negative 4 times negative 4. Okay, 0.0016, so I apply a fourth root. So I go 4 second caret 0.0016, and I get a rational number, 0.2, but it could be positive or negative. Okay, and then I put a fourth root over the whole fraction. You could put it over each number if you wanted to. You can do it like that, the whole thing, or it doesn't really matter. So positive, negative. And you can also do them separately. So I can take the fourth root, 4 second caret, 625, and it's 5. And I can go 4 second caret, 1,296, and I got 6. Okay. Or I could do it all together. 4 second caret, 625, ABC 1296, and it comes out the same. Okay. Now, in the next section, find the two real solutions of each equation. Okay, we have x to the second power equals 49. Okay, so x equals. So to get rid of a second power, you cross it out and you apply a square root, So the square root of 49, well, 49 is a perfect square, it's 7. But it could be positive or negative 7. Okay. X to the fourth equals 625. So I cross out the fourth and now I apply a radical, but it needs a degree of 4, not a 2. But it's even, so it could be positive or negative. So the fourth root is 625. Well, there's 6. You can use the caret key or look at your sheet. The fourth root of 625 is 5. So it could be positive or negative 5. X to the second equals 64. So again, we apply a radical of a degree of 2. And it's going to be positive, negative, and what times itself? 64. It'd be 8. Okay. And then x to the fourth equals 16 over 625. 16 over 625. What I like to do personally is apply a fourth root over both the numerator and denominator separately. That's just me. Okay, so the fourth root of 16 is 2, and the fourth root of 625 is 5. Could you put it over the whole thing? Yes, but I prefer to do it separately. It helps me see better what happens. So x equals positive or negative 2/5. Okay, and then the final part we have here is you're simplifying the expression. Okay. If the radical doesn't have a degree, it's automatically a 2. There's no such thing as a first degree radical. That's ridiculous. So if it doesn't have one, it's a 2. So we have a radical of a degree 2, and then inside of the radical we have 16x to the power of 8. So here's what I would suggest you do for today to start with. I would put square root of 16 and then square root of x to the 8th. Okay. So let's evaluate the square root of 16. So the square root of 16 is 4. Okay, 4 whole. Now x to the 8th, here's what we do. We're going to write 8 factors of x because it's x to the 8th power. 1, 2, 3, And then we're going to split up this radical so it covers 2 x's at a time. Why 2? Because it's a square root. If that was a cubed root, it would be 3 x's at a time. Okay, so square root, 2 at a time. Now x times x is x to the second. X times x is x to the second. X to the second, x to the second. Now the square root and the second power cancel, so for every one of these two groups of 2, I have just one factor of x. Just put a factor of x above, okay? So you got 4 from up here, and you have 4 whole factors of x, so it'd be 4x to the 4th, okay? Okay, the cubed root of a to the 6th times b to the 9th. So that's a times operator if you want to put the dot between them. So break up your factors. You've got a cubed root over a to the 6th and a cubed root over b to the 9th. So a to the 6th, that's 6 factors of a. And now we're going to be putting the radical over 3 at a time because it's a cubed root. So there, cubed root, and there, cubed root. So a times a times a is a to the 3rd, and that would give me a whole factor of a. A times a times a is a to the 3rd, and the cubed root and the a to the 3rd cancel out, and they give me one factor of a. So a times a is a to the 2nd, okay? Now b to the 9th, that's 9 factors of b. So b times b times b times b times b, there's 5, 6, 7, 8, 9. So cubed root, remember 3 at a time because it's a cubed root. And then every one of these, you don't even need to write b to the 3rd because you know it results in a whole factor of b, every root. Okay, so b times b times b is b to the 3rd. So the result of this is a to the 2nd times b to the 3rd. Okay, next one, the 4th root of x to the 8th times y to the 12th. 4th root of x to the 8th times y to the 12th. So let's break up the radical, 4th root of x to the 8th and the 4th root of y to the 12th. So x to the 8th. 8 factors of x. Okay, now we're putting them around 4 at a time. So it's going to be a 4th root over x to the 4th. Then again, now there's no x's left over, so we have 2 full factors of x. So that will be x to the 2nd times y to the 12th. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So over 4 at a time. That'll give me a y there, a full factor of y. A y there, a full factor of y. And then a y there. So that's 3 factors of y, which y times y times y is y to the 3rd. Okay, next one. This would be a square root if we don't have a root. So the square root of 81x to the 4th. So I'm going to have the square root of 81 and then the square root of x to the 4th. So 81, that's a number base. So I look up the square root and 81's there. So it equals 9. Okay. So I put 9 times and then x to the 4th. And you'll be putting it over 2 at a time, okay? So 2, 2. The square root and x squared give you one factor of x, and the same here. So that's x to the 2nd, so 9 times x to the 2nd. Okay, then on the back side, okay, the cubed root of a to the 12th times b to the 15th, okay? So we got the cubed root of a to the 12th, and we have the cubed root of b to the 15th. So a to the 12th, a times 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 a. So 3 at a time. Every time I can do that, because they're a cubed root, and with a to the third, the root and the power cancel, and that gives me a full factor of a. So that would be a to the fourth. Now some of you are like, is there a little easier way to do this with these variables and these high exponents so I don't have to write it out? Yeah, there is actually. What could you do with 12 and 3 to get 4? What operation could you do with those? You could probably divide, right? So 15 divided by 3 would give me 5. But you can't do it with the number. The number you got to break up, okay? So we got the fourth root of 256, and then we have the fourth root of x to the 12th, and we have the fourth root of y to the 16th. You can't divide on the number. You have to take that to the sheet. You can't divide 256 by 4. The fourth root of 256 is equal to 4, so we have a factor of 4. Then, if you didn't want to write out 12 factors of x, what's 12 divided by 4? You can take the exponent divided by the radical degree, and that would be x to the third. And you can do the same thing here. 16 divided by 4 is 4. Now, what happens if it doesn't divide evenly? Well, we're going to look at that in future lessons, but I think today they're all going to divide evenly.